Hi everyone, thank you for joining our webinar. With me today, Danilo. Danilo, thank you for joining.
Thank you, Ram, for inviting me. I'm really excited to do some live hacking and do some debugging.
Yeah, actually I need to thank you for inviting me for AWS in London. The offices here are great. So I think let's get started, right?
Yeah, definitely.
Perfect. So we'll talk about serverless observability workshop in this time. With me, as I said, Danilo. Please feel free to introduce yourself.
Oh yeah, so I joined AWS almost 7 years ago, and now I'm focused on serverless technologies. I really fell in love in 2014 when we launched Lambda. I really see that serverless is showing the way we are going to develop applications in the future.
Mm-hmm. Yeah, and myself, I'm Ribenzaft, the co-founder and CTO at Epsagon. I fell in love with serverless the same. I think it started with some Alexa skills and then, some more robust applications, and now Epsagon, which is definitely totally serverless. It's fun. It's fun to build applications this way.
Yeah, so serverless, if you don't know it, it's a way of building application without having to think about the underlying infrastructure. So you don't need to provision servers, manage servers, patch servers. And two of the main features that I really love is that everything is automatically deployed across multiple availability zones on AWS. That means that you use multiple data centers without having to think about that. And then we are ready to scale, so you can have one invocation for your functions every month or thousands of invocations per second, and the infrastructure will scale automatically. And you only pay for value, so you only pay for the hundreds of milliseconds of the execution of your business logic into functions, or if there is an update on the database, or if you're storing some data. So really you pay only for something that is providing you some value.
Yeah, I think I've heard somebody says that serverless is the ability to scale to zero. It means that you're not going to pay for something that you're not using. And in this case, Lambda or other resources that we're going to use in this workshop are definitely serverless.
Yeah, that's a good way to see that. And what I've seen is that when customers start to use serverless, they can build their application very quickly. But then when you're in production, you need to be careful, because you need to understand how to experiment with your application to introduce new features, listen to the feedback from your customer, and iterate very quickly so that you can always evolve your application. And if you do that fastly, then at some point you will break something. So you need to be able to understand what you're doing.
Mm-hmm.
And to do so, we talked with lots of our customers, and we found out that there is, we created this list of recommendations, of suggestions to create modern applications. And the idea is really that you should simplify the environment that you use, reducing your exposure to operations, so that you can really focus on the business logic you're building, and serverless can really help there.
Mm-hmm.
It's also important to reduce the impact of code changes. So if you have a large code base, if you change something to add a new feature, it's very easy to have impact in other parts of the code. With microservices, you create boundaries around your business logic, so you can in a much easier way contain the impact of code changes. So I think this is something that especially some of our large customers understood a few years ago, and now we're seeing adopting more and more.
Mm-hmm.
And then when you adopt microservices and you have tens or hundreds of applications to manage, automation is really important.
Yeah.
Otherwise, you really can't do.
Nobody can manage more than 100 microservices by himself.
And it would just suck your energy to do so.
Yeah.
So to do so in an efficient way, I always recommend to manage all your application infrastructure and code in a single template file. So managing infrastructure as code is really important.
Mm-hmm.
And then when you have your infrastructure together with your application code in a single repo, you can very easily create multiple environments and implement continuous integration, continuous deployments into maybe a test environment and of course your production environment. And CI, is really giving you quickly a feedback on how there is an impact in the code base. So when you add a feature, you can really get, as a developer, a quick feedback on what is happening in your code base. Continuous deployment moves that a step further, because you get a feedback quickly from your customers too.
Yeah.
Final point is security. So I always say security is part of the development. It's not something that you add at the end.
Mm-hmm.
So you should definitely think about that. And of course, observability. This is something that not every developer understands. So I think it's very important to say that as a developer, you are responsible of making the application, the component of your application that you build, observable. So that from the outside, you can understand what is happening inside. So not just from an infrastructure point of view, so how much are you using CPU or the network, but really from a business point of view. So how many transactions per second are you doing? Are those the correct transactions that you expect?
I think what happened with serverless is that people can, or developers can iterate much faster and ship much faster, and sometimes they tend to forget the cruciality of having something in production that need to be observed when something bad happens, or when they want to monitor their business ongoing and see how much traffic do they hit, what is the business forecasting, and so on. And it's easy to get started with serverless, but you need to make sure you've got this in place before you're getting into production.
Yeah, you're absolutely right. I think that's the second step. Now, the first step is that you can build something fast, but then you need to keep the fast pace.
Exactly.
And so observability is really important, because especially in a distributed environment where you have different microservices, components interacting, you must understand what is happening, and if something bad is happening, as soon as possible, so that you catch maybe the problem when it's still in a degraded state, and before this is causing an outage. And especially when you have dependencies in a distributed architecture, so if one service is starting to slow down, understanding the impact and doing root cause analysis can be tough. So that's why you really need to have the possibility to understand what is happening and where something unpredictable is happening as fast as possible.
That's true. Now let's talk a bit, or not a bit, let's talk about observability, the reason that we all met here. So I want to talk first about the changes that happened throughout us getting to serverless applications. And the first and most notable one is that we've got no more access to the underlying infrastructure. It's not the same EC2 instance that we can SSH into and get some more logs or more data, because it's not available for us now when we're using S3 and Lambda and SNS. We've got a service that is working for us, and it's better. Now, also, as Danilo mentioned, these kind of applications becoming more and more distributed and more asynchronous. We'll give an example actually in this workshop, but when you're ending up with almost 100 resources talking to one another in an asynchronous manner, trying to correlate between what's going on between these services, it's very tough. I mean, it keeps growing and it keeps changing, and you need to be on top of what's going on in the application.
Yeah, and being asynchronous is really important, because if you create a distributed architecture where all the components exchange information in a synchronous way, you're just building a distributed monolith, and then you're just getting the worst of the both worlds of the monolith and of the distributed applications.
We're calling it the serverless spaghetti. Also, there is the cost that needed to be considered. I mean, it's really great because you don't pay per use. You pay per use, you don't pay for any idle time, but when you're hitting more and more traffic, you need to be on top of what's going to be the cost calculation by the end of the month and understand your business implications to it. And last but not least...
one thing on cost. I think it's really important that it's so fine-grained cost that you can really understand the cost of maybe a single transaction.
Exactly.
So there's some discussion now about what they call FinDev, no? But the idea is that really, if you want to build a business case around your application, you can really understand how much each of your customer costs, and maybe how much even each feature costs, so that you can understand what you can give, for example, in your free tier, and what you can give in a premium tier, and so on.
That's amazing, because every service is separated and you pay only for the amount of requests that you're doing, so you can actually distinguish for each and every feature and each and every customer how much it costs for you. And last but not least, we're changing an environment, and we've got some new things that are being introduced that we need to make sure that we're aware of them. So in the current execution environment for a Lambda function, we've got a duration that we can run up to 15 minutes. These 15 minutes, I think it's not a limitation. It's more about the concept of running things very fast, very quickly. Usually I tend to say that functions shouldn't run more than a minute or more than maybe, let's say, a few seconds, but it really depends on the use case. So this is one thing. The other thing is also memory. So I'm not sure if many of you know, but when defining a memory to a Lambda function, it not only defining how much allocated memory we can use, but also how much CPU share and I/O share, like network share, we're getting. So it really affects the performance of the Lambda function.
Yeah, and by the way, not everybody knows, but when you reach 1.8 gigabyte of memory, you start to see 2 cores inside the Lambda execution environment. So if you want to use all the CPU power that you get when you have more than 1.8 gigabyte of memory, you need to have at least 2 processes or 2 threads.
Exactly. Also, the Lambda functions, or in general functions, are stateless. So it means that you need to keep the state somewhere, either a database or a storage or any place. It means that you need to interact with some APIs, and it's crucial because you're going to interact with lots and lots of APIs.
Yeah, and this is an example where some restrictions actually put you into good behavior, no? So we always said this building stateless application is better for scaling, for availability, and now it's almost like the platform is bringing you to that.
Exactly.
To do that.
Now, last thing is the cold starts. It's a thing that happens when a new instance for the function is being instantiated. Now, we don't have much to do with it, but it's something that we need to keep in mind that it can happen, it can affect our performance, but I think that over time it will be more and more negligible.
Yeah, we worked a lot. So currently, when we look at the data that we can collect, we do everything that is possible on the management of the infrastructure side. So most of the cold start that we see is really the setup of the client application, so the startup of the execution VM, for example, if you're using a Java VM or something like that, and also the instantiation of the code. For example, again, in a Java environment, the new AWS SDK is more modular, so that it's faster to create objects like the S3 object that you might use in your function. So think that your tuning can be more important than what we can do. Yeah. The only exception probably is the VPC now. Yeah. So when you connect a Lambda function to a VPC, it can take a few seconds because we need to provision an elastic network interface.
But I heard that at reInvent they promised that this year it will be faster.
This year we're going to completely remove this additional time because we are going to change the way we provision networking, so it will be at function creation, not at during the execution of the function.
Amazing. Now, before we hit the workshop itself, last thing that I would like to talk about is that serverless is somewhat a distributed application. And in distributed application, we need to make sure that we're monitoring all of our resources and not individually. So it means in this example, we're using API Gateway and SNS and SQS and SCS and DynamoDB. So we want to make sure everything is being covered in the same place rather than looking at each and every resource individually. Also, when we're talking about the performance, we want to monitor the performance from an end-to-end perspective and not for each and every individual resource, because end-to-end performance will tell us how long maybe a customer waits until he gets an approval mail for the business that he's doing. Also, when we're troubleshooting something, we usually use logs. I mean, every developer has his own logs that he can log into, but if these logs are not correlated, so trying to correlate logs between one Lambda function to another, or maybe between few services, can cause a real headache, especially if you're having really high traffic. So correlation is really crucial.
Yeah, and as you said, lots of these techniques are really techniques that comes from distributed application, from microservices, not something unique to serverless. So lots of questions that I get around serverless actually can map to any distributed environment.
Exactly, and the last one is obviously distributed errors. When something bad happens, for example, in the second Lambda, you want to make sure that you can do a real root cause analysis and go back even before to the first Lambda or the user that triggered that API gateway to start the invocation in the first place. Great, I think we covered the observability stuff. Now let's roll our sleeves and dive into the real workshop. So we're talking about Twitterbot. All of us love Twitter. If you love Twitter, please raise your hands now. Hopefully I'll be able to see you. Now what we're gonna build for this specific example is to allow us to get new influencer names according to our hashtags. So personally, me, I really love hashtags like serverless and Docker and AWS and Lambda and so on. But keep tracking of who's posting interesting stuff and who is the influencer for these hashtags. It's really hard. So what I want to do is to build an application that will collect all of my hashtags every few hours we'll run, or maybe a day we'll run a Twitter. We'll collect the most popular tweet that there is out there, and will report me when there is a new influencer. For example, if you'll post something new, and I'll say, okay, Danilo seemed to be really a rock star in serverless. I want to follow him, so I want to be aware of that. So this is the application that we are going to build. For that, our system requirements are obviously an AWS account. Free tier is definitely okay. We're not gonna cross any free tier thresholds. On top of that, we're gonna use Git, Python, and the serverless framework for deployment. All of this are available free for you to download in the official websites. And for the workshop, we're going to use the monitoring workshop predefined repository. So let's have a look at what's going on in this repository now. So as you can see, it's publicly available under the Epsagon repo. And what we're going to do is go through branch sequences. So it's already mapped in an order, starting from 1 to 5. So we're going to cover each and every step. We're going to learn more and more stuff as long as the step goes. And in each and every branch that we'll go through, there is a thorough README that we will follow. You can follow this as well. You can stop the webinar and maybe come back to each and every point later. But this will allow us to cover everything for this workshop. I think we're ready to get started. So we got 4 steps that we're going to review. Let's start with the first one. So for the first one, we're going to deploy the first building block in serverless. It includes an API gateway and a Lambda function. For those of you who don't know, API gateway allows us to build an API endpoint for GET, POST, or any other method. It has lots of features, including custom domains, including regional or endpoint optimized deployments. And this will allow us to get the top tweet from the Twitter API. So what we want to do in this building block is to give it let's say, for example, a hashtag, and it will tell me what is the top tweeted one for this hashtag in Twitter as of now. So let's get started with deploying. In order to deploy, I'm going to use my terminal. In this terminal, I'm going to jump from the master branch all the way to the first branch. So for that, I'm going to use git branch -a to get all branches. I'm going to jump to the first branch with git checkout. And now I'm in that branch. Let's start first with deploying, and then we'll get to running it actually. In the meantime, while it deploys, I'm going to review a bit the code that we're doing now. So first of all, before starting the deploy, in your case, you'll need to follow the install dependency, and then you'll be able to deploy. Now, in the meantime, let's maybe cover the basic code in here, and it's the Twitter service. In the Twitter service, we can see that we got the main handler, the get top tweet, that get the event and the context. In our case, the event is the API gateway event. So from that, we're going to extract the body. In the body, there will be only the topic or the hashtag that we're interested in. We're going to initialize the Twitter API. In this Twitter API, I've already loaded the consumer keys and secret and the access keys as well under the environment variables. And we're going to get the latest top tweet according to the topic that we're looking for. We're going to get only one. I mean, I'm just going to get the one that is most popular and most recent one in the result type. And I'm going to return the body towards back to the customer, which in this case, this is me.
So we get the most important influencer for the last day.
Exactly. It's for the last day. The result type mixed means that it should get a mix of both popular and recent. So
okay.
Twitter will handle this for me. Let's go back and we can see that we already managed to deploy it. Now, in order to run it, we got the API endpoint that we're working with. I'm going to copy the command that I've already pasted in the README using curl. And the last thing I just need to change is just the API that I just got. So So the API that I just got is this one. I'm going to execute it, and as you can note, I'm posting a request with data serverless. So this is the hashtag that I'm interested in. So let's see what comes up. So I can see that there is a Cloud Expo screen name, tweet something like, did you know Cloud Expo is the most influential technology, which is nice. We can run some more, for example, let's say serverless Lambda. Let's hopefully get that there is something, but honestly, we don't see anything for serverless Lambda. It's really interesting, but...
Wow, we got an error.
Yeah, so we got an error, but it's actually not even expected. I thought I might get something, but actually that's time to see how observability comes into place. So in order to troubleshoot it, we'll go to the AWS Console. I've already opened the AWS Console, and Danilo will help us to cover the dashboard in here.
Yeah, so we updated last year the Lambda console a lot to make it easier to understand what is happening with your application. So you have a dashboard that gives you an overview of what is happening for your account in the region. Then we also created an application section where you can see for each application aggregated metrics. An application is actually a CloudFormation stack that has at least a Lambda function inside. And then you have the layers where you can group the dependencies of your function and connect that with your function without having to upload the dependencies every time you do a function update. And in the function, you see, of course, the list of your functions. So the first one here is the one that we're using for this workshop. And this is the view of a single function. So we start from the top. You see for your function if there are any layers. There are no layers here. And what are the services that can trigger the function on the bottom left, and the services that this function has permission to interact with on the bottom right. So in this case, is the only one that is always required, that is the possibility to write logs. Otherwise, I think observability is very hard. Then you see the function code with the embedded editor and other stuff. Since we're focusing on observability, this is the debugging and error handling section where you can enable active tracing with X-ray, with AWS X-ray. And you can also enable the dead letter queue where we can send the events that create an error in your function so that you can analyze them offline.
Yeah. Also, there is the memory, obviously, that we can configure, and the timeout, which can hold up to 15 minutes in our case. Now, I think the interesting part would be to cover maybe the monitoring tab.
Yeah, the monitoring, this is the monitoring for a single function. So you see here all the metrics that we automatically provide with CloudWatch for Lambda. So the number of invocation, the duration, the errors, the iterator age. If you're consuming, for example, a Kinesis stream, it can tell you how old is the data in the stream, and if you're getting behind. If you're getting throttled, because every account has a limit, so the default limit is 1,000 concurrent execution per region. And here you can also zoom into the X-ray console for tracing, and maybe the more important one is to go straight into the CloudWatch console.
We actually had a problem, so it makes sense now to go to the CloudWatch and see what problem happened.
So for each function, you get a log group, and each log group has multiple log streams. Normally, each log stream is created by a different execution environment. So if you see more streams, it's because there are multiple environments, or if you do an update, we create a new environment. From here, you can search the whole log group. So you can, for example, set some limits, like I want to search everything that has happened in the last hour or the last day. Or if we go back, we can just click into a single log stream and see what happened with the execution.
Okay, so in this example, we actually see our first run, which was successful. By the way, if you don't know how to read CloudWatch logs, every invocation starts with a start indicator and ends with an end indicator. After the end, there is a report line, which actually is good for monitoring purposes, including how long did the function run, how much memory was it using. In the second one, we're seeing that between the start and the end, there is an error, a Python traceback. And in this example, we're seeing the line that it got the error and list index out of range.
I think it's really the standard error that we all get when we create a new application.
Exactly. It's almost the basic error. Now, top tweet at the first location. So let's try to go to the code and understand what went wrong. We'll be able to see that we're expecting to get some top tweets in this example, and we're expecting to have something in the list. But if we're sending a hashtag that doesn't have any tweets to it, so we'll get an error. Now, in order to fix it very quickly, let's review the exact fix that we're going to have.
I can post something on the serverless Lambda hashtag and fix it that way.
Correct. But let's see again for Git branches. The fix has already been made for you. So if we'll do a Git diff between the first branch and the second branch, we'll be able to see that now we're assuming that the body is none. And if we did get a body in the top tweet, if we did get a top tweet from before, we will set the body to something with the screen name and the tweet. Otherwise, the body will be none and the return will be none as well. So this helps us to fix. You saw how logs, it's like the first place that we're going into troubleshooting.
Yeah, the important part here was really to find the error in the code base.
Exactly. Now, a few more examples that I would love to show for you in order to maybe remain in the CLI and run things something faster. So let's start with invoking the function locally. So in this example, I can use the serverless framework to invoke a function. Let's give it some example. So I'm telling it I want to invoke locally the function getTopTweet with the following data. In this JSON, it just mimics the body that I'm sending to the function, and we can see that it actually works. So this is a good iteration. If we're going to fix the function, we can maybe first invoke it locally, make sure that it works, and then upload it to production. The other thing that I would like to cover is showing logs maybe from the terminal, because sometimes it might be a headache to go back and forth always and open lots of tags. So in this example, I can do SLS logs. Sorry, in my case, it's a different AWS profile, workshop. So in this example, I can see all the logs that we just saw, the first one and the second one with the error. I can also add to that command -t, so it will tail. So I can leave it open and run my function and verify that everything is working properly.
Yeah, I'm one of those persons that loves to tail the logs when you're prototyping and building an application. So it's something I love.
Exactly. Let's go back to our presentation. So in this scenario, we learned first how to build a first building block, but also to invoke a Lambda function with Lambda, with the data, running it locally to debug, understand our resources within the AWS Console, understand what is the configuration, and how do we tackle the logs. Let's move on to the next step, and now we're going to build another building block. This time, I want to maintain a list of topics that I'm interested in. I don't want to constantly send the topics that I'm interested in to the first Lambda. I want to maintain a bucket, an S3 bucket, with all the topics that I'm interested in. Now I want to have an API to add a topic. I don't want to manually manipulate the file in the S3. I want to have an endpoint that I can say, oh, I found out a new hashtag. Let's add it to the S3 bucket, and from there, everything will keep tracking. So let's see how do we do it. Let's first get into the right branch. So let's again list all of our branches. In our example is the 2.1 adding S3. I'm going to check out into that branch. And in the meantime, I'm going to run a deploy command that will allow me to add this S3 bucket. Now what happens behind the scene, we can review this time the serverless YAML. So let's open the serverless YAML to see how a more complex one looks like. So I'll just review it briefly in the meantime that it's being deployed. So we're having this monitoring workshop service. We're going to use AWS as a provider with the specific region that we want to. Now we used before the getTopTweet, but this time we're going to add another one as add topic. And I'm telling him that my event is based on an HTTP at the endpoint of /add topic, and you need to use the post method and not the get method. And I'm going also to let him know what is the bucket, the target bucket in the environment variables that he can publish it into. as you said, having infrastructure as code is great because I don't need to set up things manually. So in this example, I'm also defining a resource. This is, by the way, the serverless framework that translates into a CloudFormation template, which is great. It's infrastructure as a code. So I'm defining the S3 bucket that will be deployed for me for every time that I'm deploying without me needing to manually configure these kind of buckets or any kind of resource.
Yeah, and if you create multiple environments, like a test environment, a production environment, each one will have their own bucket,
Exactly.
and you avoid possible errors.
Exactly.
Like one environment going to the other.
Yeah, so we're seeing that we got the add topic endpoint. Now on the README panel, we'll be able to see how can we use that to add some more topics. So I'm going to copy the command over here. And as you know, we need to update our REST API ID. So I'm gonna copy that. And now what I'm saying to the endpoint is, okay, I'm going to add a topic. This time is the serverless topic. So let's hit the enter and we'll see again, message internal error. So this is again a problem. I'm not sure what happened, but now I've got the tools for myself that I can understand what went wrong. And in this example, I'm going to check what is the log, because I saw that the logs give me a nice view of what happened. So I'm going to use the same command as before, but this time I'm going to watch the add topic. And let's see what logs it yields for me. So we're seeing that it got the topic that I've requested, the serverless, but this time there is a traceback. Can you maybe help me understand what went wrong in this traceback?
Yeah, I see some access denied. So it's very common on AWS that you have this kind of errors because you have to give permission for every interaction.
Exactly.
So in the role of the function. So in this case, I assume we need to be able to interact with the S3 bucket.
Exactly. So in this example, if we'll get into the Lambda function that we got, we'll see that there is no any permission to write to the S3 bucket. So we're getting into the...
Yeah, it should be here on the bottom right.
Exactly.
Below CloudWatch logs.
Exactly. Luckily, we've already made a fix for it, and let's see how this fix looks like. So in order to do that, we're going to diff between the two branches, the one that fixes the permission. And we can see that to the serverless YAML, which actually translates into a CloudFormation template, we're adding a YAML statement that allows us to get object and put object into this S3 bucket. And this is the ARN for the bucket.
Yeah, the get and put needs also the path to be like an asterisk or the subset of the path.
Exactly. So we're going to check out this branch and we're going to deploy it and make sure that it works. SLS.
Let's redeploy.
Exactly. We'll redeploy. We'll make sure that everything is working before jumping on to the next step. In the meantime, while it's being deployed, let's cover what we are learning in this step. So this time we learned that we need to define permission. For everything that the Lambda is interacting with, we need to make sure the permission is granted, and we need to make sure we're not giving too excessive permissions. This is a common issue that you'll say, okay, let's give administrator access for that Lambda, but it's not a good practice.
Yeah, also giving asterisk access to a whole service. Like, okay, I give full access to S3, it's a very wrong practice, also in development, because one thinks, okay, I will fix this later, but you never know if someone forgets. So never give S3 asterisk. That means you can do everything on S3, because that means that you can create bucket and also delete existing bucket in that region.
Exactly.
So always give the minimum amount of permission that you need.
Exactly. Let's go back. At this time, we're already seeing that it's deployed. So let's try maybe to run again the curl command to add a topic. And let's see that this time it works.
Yeah, it worked.
We've got no errors. There is a new topic in our bucket list, and it worked perfectly. If we will refresh our page, we'll also be able to see that we've got the new S3 permission in this case. So as you can see, we got it. Perfect.
It's really good from a visual perspective to keep everything under control.
Exactly. So we're ready for the third step, and this time we're actually not building another building block, we're composing all together. So now what we want to do is actually to automate all this process. In order to do it, we're going to use many more resources. We'll start with a cron trigger that will trigger every 5 minutes our Lambda. This Lambda is the main handler that's responsible for everything. We'll soon see that there might be a problem with making such a monolith architecture into a serverless, but we'll get into it soon. The thing that this Lambda will do is to get all the topics from the S3 bucket. So all the topics that we're adding to that bucket will be listed here. It's gonna execute for each and every one of them a query to the top tweet API to get the top tweet for that topic as well. It's going to check against the DynamoDB that holds all the recent topics and the latest influencer that we found out. And if it will find a new influencer, it will publish a message to the SQS, and it will trigger the second Lambda of alert new influencer. Currently, this Lambda only doing, it's only doing messaging printout to the console log, but we can put it into a Slack, we can put it into email or anything that might resonate for us. So let's get started with deploying this one. Again, let's do a git branch -a to get the branch. This time is the cron job, so we're actually converting our application, our two building blocks to an application, and we'll deploy it. In the meantime, while it deploys, so let's see the way it works behind the scene. So we'll get into the main function in here, and this main function is the handler. I'll open it in Sublime again. And in this example, we're already seeing the add from API gateway, the add new topic that we already see, but we're seeing the scan all topics. So this is the main entry point. And what it does, it gets all the topics from the bucket. It gets all the topics names out of the file. And for each and every topic, it scans the topic. So scan the topics mean that it will trigger a new Lambda function that will query from the API and get the information towards check against the DynamoDB whether it's new or not, and will publish the influencer to the new influencer queue. The influencer queue currently only what it does is to print the event, but as I said, we can change it to any thing otherwise that we want to. So our deployment is still running. It should be hopefully ended soon, and once it will be finished, so we're gonna use the API to invoke our new function, the new scan topic function. In this example, the command will be an SLS invoke. Okay. So we can see that this function has been deployed, and now we're going to want to invoke it manually. So we're using the SLS invoke, but this time I'm not going to invoke it locally. I want to actually invoke the real Lambda function. So I'm going to use -f for scan all topics function, and then my AWS profile, which is the workshop. So let's trigger it. Hopefully, if everything works correctly, we should get nothing because it works, and that's perfect. But now let's see what happens when our application grows and it's getting more and more traffic or more information to parse. So for that, I pre-made a list of topics, interesting topics that I'm interested in monitoring, including serverless, AWS, Docker, container, Git, NoSQL, Redis. I'm interested in lots of technical stuff. And in order to upload it to my S3 bucket, I'm going to use a predefined command listed on the README. So I'm going to copy the command, and I'm just going to change the AWS account ID to my topic list bucket name. In my example, is this number. So I'm going to upload this file, and I'm getting an access denied because I forgot to mention the AWS profile that I'm working with. So I'm going to mention that it's a workshop profile. And now it's working. By the way, these things can happen sometimes locally. And now we're going to give another run to that function. So we're going to invoke it. But this time I don't think we'll handle it correctly. We might end up in a different way. We're seeing that it's taking long, and actually we got an error message, a test timed out after 6 seconds. We waited 6 seconds, but nothing worked properly.
It's quite suspect when you see this rounded time error, no?
Exactly. It means that we crossed our 6 second threshold. So we can either increase the duration, but it doesn't make sense because this list was just, 15 topics. What happens when we'll have 100 topics on 1,000 topics that we're interested in?
We're probably not using efficiently the function, because when you do lots of different API calls from a function, you should do stuff in a more asynchronous or parallel way.
Exactly. So by the way, in order to find when a Lambda function is running out of time, you'll see that at the logs there is right after the report line, the task timed out after the X amount of seconds that you defined. Let's try maybe to understand visually wise what happened wrong with our application. And I think it's pretty notable because we created some sort of a spaghetti monolith where there is a single cron job Lambda that handles all of the topics, and it waits for each and every topic with the Lambda that gets the top tweet. So it means that if I've got 15 topics, this Lambda will wait 15 times for that Lambda as well. It doesn't make sense to wait for it. And actually here we learned that we can get up and running pretty quickly, but we want to make sure that we're designing the right system. The right system in this case would be to transmit an asynchronous message and let our services speak for themselves rather than a single one that collects all of the data and gather all the information. So let's see the way to fix it. And the fourth and the last step would be to redesign it with an asynchronous message distribution. So in this example, we're going to start with the same cron job every 5 minutes to scan all topics. The scan all topics will just get the topics from the S3 bucket.
Okay.
Once it got the S3 bucket topics, for each and every topic, it will spawn or invoke a Lambda manually. So instead of calling another Lambda via a synchronous event, it will asynchronously invoke another Lambda.
So it starts the Lambda and then it's not waiting for the Lambda to terminate.
Exactly, it forgets about it. Just transmitting something to another service says, here you go and handle it. And this Lambda, what it does is to get the Twitter API for the topic, understand if this is a new topic or not, and then if it's a new topic, publish it to the influencer SQS that will let us know that something new happened. So let's go to that and deploy this configuration for ourselves. And I'm going to use again git branch -a, this time with the fourth step, git check out. And I'm going to deploy, as always, this function. In the meantime that it's being deployed, let's see how the new code looks like, especially with the invocation of asynchronous invocation and regular invocation. We'll be able to see it under the handler. And now this time when we're scanning all topics, we're getting the topics from the S bucket as we used to, but this time for every topic we're using the Lambda client, the Boto3 or the AWS SDK, and instead of calling a synchronous API, we're invoking asynchronously this Lambda. So it means that the original Lambda, the scan all topics, won't wait for this Lambda to finish its running time. It's just sending it, a scan topic, please scan the topic that I'm just providing you, and I'm gonna move on to the next one. So even either if it's a single topic or 1,000 topics, we'll be able to fan out, this pattern called the fan out, of the work to multiple workers. This worker in this time is the dev scan topic. So it will allow us to run much faster. Now let's see what happens with our deployment, and we'll see that it's already done. That's perfect. And we already got this big topic list that I'm going to run again. And this time hopefully the scan all topics will work, right? Because it's doing asynchronous job. So let's give it a go. And we can actually see that although there is 17, or I don't really recall how many topics there are there, but there is a null termination. It means that it ended up correctly. Error. Exactly. Now let's actually see what happened behind the scene with the logs of this function. So we'll get to the function and we'll filter only monitoring workshop function, and let's get into the scan all topics to see that it ran correctly. In this one, I'll get into the CloudWatch logs quickly to verify that it worked properly. And we can see that the latest invocation was running in less than a second. That's perfect. It means that we can scale much more than that. And now let's see what happened to the specific scan topic. And this case is extremely relevant because I also want to show the new influencer. And we'll jump to the CloudWatch logs here as well. Now we're on the CloudWatch log of the scan specific topic.
Oh.
We can see that
something different now.
Exactly. We don't have just a single log stream or two log stream. We've got the number of execution that we're running simultaneously, something like 15 or even more. And now if there is problem that happens, it might be a bit harder to explore. Now let's go back to the new influencer. I'm expecting to have a new influencer as of now, like that it ran just actually right now. But let's see if it's actually ran. So I'll go to the logs, and I see that the latest invocation has been only 7 minutes ago, which doesn't make any sense because I just recently deployed this Lambda function, and I hope to see some new influencer coming out because the previous invocation, as you know, didn't end up successfully. So there are definitely some topics that are new that haven't been got to the DynamoDB yet. So we'll get into it, but we don't understand whether there are new topics or not, whether we got it or not. It's really hard to correlate what happened now and what was the trigger. So trying to correlate why didn't I got a response and get into each and every CloudWatch in here, it's a pretty headache. But let's try to see if we'll find out the exact error. And actually, luckily, we've got it in the first one. We can see parameter validation failed. So in this example, we're trying to stream a message to the SQS. The scan topic says, hey, I found a new topic. I found a new influencer. I want to publish it to the new influencer. But once it's trying to publish, is saying something like, I expected to get a QURL, which is a string, but this time it's a none type. Luckily for us, it's been on the first one, but it could easily get
each of those, yeah.
Exactly, try to get it in each and every one of these. Let's see what went wrong. This time it's actually in the serverless YAML, a misconfiguration that can happen to any one of us. So we will see that the scan topic, usually we knew that scan all topics was the one that transmitting to the SQS, but now it's the scan topic. But it's got no environment variable of the influencer SQS.
Okay.
It means that it doesn't know which queue to stream into. If we'll jump into the handler to the scan topic, so we'll see for under handle new influencer, we're publishing the SQS message to a QURL, but this environment doesn't exist. That's why it results in none rather than a real string. So to fix it, obviously, it's pretty simple. We need to make sure we can configure the SQS or the right environment variable to the right function. In this example, it's not even needed in here, so we can just remove it from here and move to the second Lambda. Let's go back to our presentation and see what we learned in this example. So first we learned that we've got a real distributed system talking asynchronously to each other, and sometimes logs, for us, for example, it's been pretty easy, but think of thousands hashtags that running continuously, trying to get the right log at the right time and correlate between this function to the function before that, or even to the triggering function, might be really hard.
Yeah.
And also something worth mentioning, in this example it didn't happen, but for when Lambda is being triggered by some resources, for example SQS or SNS or a Dynamo, there is a retry mechanism that happens behind the scenes. And this leads me to the importance of idempotency. Idempotency says in general that no matter how many times I'll get the same message, I'll behave according to expected. It means that I won't do anything twice. I'll know to keep up from where I stopped. In this example, it's important because if we had an issue in this Lambda and a same influencer would got to our Lambda multiple times, it could end up sending us 3 emails instead of 1, or doing something, I know, against Slack or where we publish our message. But it's something to make sure that we're aware of. So this happens, for example, for an SNS or an SQS, and mainly stream-based events that happens.
Yeah, building idempotent microservices is a very good tip for any kind of infrastructure or application, not just for serverless, because instead of expecting that something happens exactly once, when you have, for example, an invocation, you can just rely that it happens at least once, and that's much easier to build.
Exactly. Now let's end with a short demo of Epsagon. So as you saw, sometimes you want a managed solution for you that will give you everything outside of the box built on your AWS project. And for that, there is Epsagon. Epsagon works behind the scene with adding the Epsagon library that takes care for instrumenting everything for you. So we'll start with the architecture overview, and here we can actually see everything we built, including the add topic that adds topic to the bucket, and the cron job that triggers the scan all topics and triggers asynchronously each and every Lambda. It's really great. I mean, keeping on top of what's going on in a dynamic architecture, it's really crucial. And in this example, Epsagon takes care of it for you. It builds it automatically for you. And for each and every resource that we'll be able to click, we'll see the performance indicators for it and understand whether it's working properly or not. Now, sometimes when we want to troubleshoot a specific scenario, and in this example, it's the full scenario of a cron job triggering a Lambda, invoking multiple times the scan all topics. The scan topic queries the DynamoDB, the API gateway, and it triggers the SQS to trigger another Lambda. In this example, we'll be able to follow each and every request along the path. We'll be able to extract the exact log for each and every parameter or each and every invocation over here. And we'll be able to follow any information that went from one point to another. For example, what was the response body from Twitter, or let's say what was the item that I was scanning at the DynamoDB. Everything is visible, and Epsagon takes care for capture it for you. Last but not least, we sometimes just want to monitor our functions, make sure how many invocations or errors do we got, how many timeouts or out of memories which can happen for us, and sometimes just to make sure we're not crossing any performance indicator or any cost prediction for us. So we can also do it in a single specific function view. So this function view is the scan topic, the specific scan topic. We can see over time how it behaves. And for each and every invocation, we'll be able to see what are the resources involved. We'll be able to see the logs. We'll be able to see when it happened or the status. And everything is filterable over here, so it can easily understand or filter the interesting things for you to monitor. Other than that, the demo environment is available for you at demo.epsagon.com. Feel free to reach it. We've got a free tier and a free trial for you to get started easily with Epsagon. And I think that's it. Thank you very much for hosting me. Do you have any summary or thing that you would like to?
No, Ran. I think it's really an amazing product that you built, and helping customer debug and understand what is happening with their application is really important. So I think this is a nice workshop that can help people understand how to use these serverless features that we provide, how to do the debugging, and when you need maybe more help.
Exactly. I hope you really enjoyed this webinar. If you've got any questions or anything else, feel free to reach either Danilo or I via the Twitter, or ask here in the webinar. We'll be able to get some follow-up questions right after this. Thank you very much for joining. Thank you very much, Danilo.
Thank you, Ran. Bye.
Bye.